This is my vector model video. Okay, measurement is the extent or size of an object, and what we did in our project was, the very beginning, we measured the, our steps from walking to one place to another. We also measured our cardboard project, and we had to do a lot of measuring without rulers or meter sticks by using we used our composition books, and we used our feet to measure the length of the hallway. And then for our scale factor, we used our composition books, and we converted those. Conversion between SI units is the standard system of measurement used by many scientists. Using the same standards of measurement makes it easier for scientists to communicate with one another. Basically, it is it's a conversion with prefixes and it's basically like money. That's how I see it. So this chart shows what it is. Moving on. A vector is mainly magnitude and direction. So it's not like distance, because distance only shows direction, but a vector shows both magnitude and direction. No, I mean distance doesn't show direction, it just shows the speed, which is the magnitude. The vector shows magnitude and direction because it has arrows. Vector diagrams are diagrams that show the direction and relative magnitude of a vector quantity by a vector arrow, like in this diagram here. Vector diagrams can be used to describe the velocity of a moving object during its motion. Here's a picture to help. Unit vector notation. A unit vector notation has magnitude of 1 with no unit. By convention, a unit vector is represented by a letter marked with a circumflex. The circumflex is an accent mark that appears above the letter. It's the little hat that we put on our letters. So it just means it's a unit vector. Frame of reference is basically what we did in class today with the goldfish. Scale and scale factor is basically the ratio of any two corresponding lengths in two similar geometric figures. To find the scale factor, you have to locate two corresponding sides, one on each figure. And you have to write the ratio of one length to the other to find the scale factor from one figure to the other. In our assignment, we used our own scales. We had to figure it out, apply the measurements that we had, and then we had to make it bigger, and we had to use the scale factor for that. And then we had to make it smaller, and we had to mess with it a little bit. We had to play with it. And that's how I remember scale and scale factor by the first assignment that we did. Order of magnitude. Order of magnitude. It's not the same thing as magnitude because the numbers differ by one order of magnitude. X is about 10 times different in quantity than Y. If values differ by 2 orders of magnitude, they differ by a factor of 100. The number of the same order of magnitude have roughly the same scale. The larger value is less than 10 times the smaller value. Basically, this picture just reminds me of all the 10, 10, 10s that we have to do. And we're just doubling it by 10. That's how I remember it. And that's the end of it. Hopefully this will help me in the future.